And this scene in particular really impacted me. This double sunset with two stars of different colors. That was pretty cool. So I thought, wow, that's very kind of science fiction, but turned out maybe not that much.
Have you ever wondered what it's like to discover a brand new world? In the last 3 decades, we've found over 5,000 planets outside our solar system, called exoplanets. I'm Dr. Jessie Christensen, the lead scientist at the NASA Exoplanet Archive. This is Explore Exoplanets, The Discoverers, a series where I interview the brilliant minds behind the discovery of brand new planets. So welcome back, Etienne.
Hello.
We just established that your favorite fictional planet is Tatooine. So famously from Star Wars from the 70s, decades before we'd found any real planets around real stars, there was Tatooine. There was this famous scene of Luke Skywalker standing in the sunset, but instead of one star setting, there's two stars setting. The two stars that are the host stars of Tatooine are called Tattoo 1 and Tattoo 2, which is very interesting. And in particular, a really interesting part of this visual, if you can picture it, is that one of the stars is a yellow star and one of the stars is a red star. So this is already really interesting, right? Like George Lucas is making this decision. There's going to be two stars. One's going to be yellow. One's going to be red. We'll come back to that. What else do we know about Tatooine? It's a desert planet. It's very, very hot, and there's very little water, hence the moisture farms. And there's 3 moons. It has 3 moons. Tatooine and its 2 stars, Tattoo 1 and Tattoo 2, are in the outer rim of this distant galaxy far, far away. And I think that's basically all we know about Tatooine. So, Etienne, tell us why Tatooine is your favorite.
Yes, so actually it's because kind of this scene, as you say, at the sunset, because when I watched it, I was pretty young. I think I was 7 or 8, and it kind of impacted me. I said, wow, that's so cool. There's 2 stars, sunset, etc. And it's because at this age, I didn't go much often in cinema. And this time it was my brother who bring me actually with him. And so we're going to see that. And I remember all of the process to going to cinema, etc. And this scene in particular really impacted me. This double sunset with 2 stars of different colors. That was pretty cool. So I thought, wow, that's very kind of science fiction, but turned out maybe not that much in the end.
Do you thank your brother now for being a NASA planet hunter because he took you to Star Wars when you were 7 years old?
I don't say it's only my brother. I just say at this time that was him who bring me to cinema. So that was pretty cool.
Yeah, well, he did a good thing. That is a famous scene for many people. And I think one of the reasons it really grabs people is because it's such a fantasy scene, right? Like you've seen alien planets before in movies before Star Wars, but this just sitting on this sunset of the 2 suns and it just being so alien is really, really interesting.
Yeah.
So we checked the NASA Exoplanet Archive and we found our carbon copy for this week is the Kepler-38 system.
Okay.
Kepler-38 was found by the Kepler mission, which was launched in 2009. It was a NASA mission, 1-meter telescope in space that observed for 4 years. The system, Kepler-38, was published in 2012. It was found by the transit method, which if you've been following Explore Exoplanets, you've heard about already, but it relies on a planet passing in front of the star and blocking some of the light. In this case, what we had were 2 stars orbiting each other, so we could see dips in the light curve because of the 2 stars orbiting each other. We call it an eclipsing binary because the 2 stars are eclipsing each other. And then very occasionally, there was another quite shallow dip that would happen. And in fact, the planet that we found, Kepler-38b, passes in front of both stars. So the 2 stars eclipse each other, and then the planet is in the same plane as those 2 stars and eclipses both stars. So we actually get the relative sizes of all 3 bodies in this system, the 2 stars and the planet. So that was published in 2012. So 1 planet, 2 stars, just like Tatooine. The other reason I grabbed Kepler-38 specifically is because the 2 stars are a yellow star and a red star. It's a G star like our sun, and an m-dwarf, which is a small, cool red star. So as you mentioned with microlensing, a lot of the stars we're sensitive to microlensing events around are M stars. And most of the stars in the galaxy are actually M stars. So I just love this idea that, 40, 50 years ago, when George Lucas was imagining this scene, we hadn't even found planets around real stars yet, let alone planets around binary stars. And he's imagining a planet around a yellow star and a red star. And we have systems like Kepler-38 with a yellow star and a red star. So that's just really, I love that idea.
Yeah, that's quite impressive actually. How good he made that.
Yeah, it was an amazing prediction. So Kepler-38b, I will say the planet is a bit bigger than Tatooine. So Tatooine is shown in Star Wars as a rocky planet.
Yeah.
Rocky planets are hard to find. They're quite small, although microlensing is one of the few techniques that's actually sensitive to rocky planets. So Kepler-38b is more Neptune-sized, but it is hot. It's probably about 200 degrees hotter than the Earth. So, probably no one's very comfortable there except the Jawas. Okay, folks, so there you have it. Today's carbon copy is the Kepler-38b system, which is very, very similar to Tatooine in a lot of ways and very dissimilar in other ways. So let's get back to Etienne. Are you looking for more planets? Tell us what you're doing now.
Yes, so actually, I joined IPAC. At IPAC, I joined the Microlensing Roman team, which is a team of scientists and software engineers that start to write the software that's going to be used by the Roman microlensing mission. So Roman is a next big NASA mission that will be launched in 2027 and has several main scientific topics, and one of them is actually to do a microlensing survey towards the galactic center and to detect planet via microlensing. So the goal is to obtain a massive catalog of planets that are actually very complementary to what Kepler and other methods have found, because transit and radial velocity are methods that are very sensitive to planets that orbit quite close to their host, while microlensing, we are more sensitive to planets more distant. So to put that on the solar system scale, let's say transit and radial velocity are more sensitive to planet in the orbit of Venus, inside Venus, let's put it like this. Mm-hmm. While microlensing, we are more sensitive to Jupiter or Neptune orbit-like. So after the completion of this...
There's a really good graphic that shows where Kepler found planets and where Roman is supposed to find planets. And you can see that the two populations are complementary, but they overlap really interestingly right near Earth, which is one of the numbers we really care about. How common are Earth-like planets?
Yeah, exactly. So this team, we are building the software to be able to start from the image coming from the telescope to actually obtain details about all of these planets. So we expect to find about more than 1,000 planets. So we're going to need tools to reduce the data, basically. So this is my main project right now at IPAC.
Before we let you go, is there a fictional planet you'd really love to find?
Well, I would say nature is always very exotic and also often have very nice surprise that nobody can predict. So I would prefer to find something very unique.
I see. You want to be surprised.
Yeah, that nobody thought before.
Okay, fantastic. Oh, yes. Nature has much more imagination than we do. It's been super interesting, looking back at all of the different kinds of planets that have been predicted by science fiction and fantasy, and how many of them have turned out to have real world counterparts. Yeah, nature thought of that. Nature did that. That's cool.
Actually, with microlensing, we are sensitive to what we call free floating planets. So there are planets that traveling alone in the Milky Way, so without host. And we already found a couple of them. So that's a good example, I guess.
Awesome. Okay, it's time to answer some questions from the audience. I pulled this one this week specifically because Etienne is here and I knew that he was going to talk about white dwarfs. So one question we got was, can observing planets around other stars tell us about our own solar system's future? So Etienne, what do you think about that?
Um, yes, it's actually a very good and, and deep question because before we knew any planets, the formation theory were based only on the solar system. So we thought, okay, so planets should form like this, and then we start to find new planets that were really out of totally different than the solar system, and we say, oh, okay, so our models does not predict that at all. And so to find this kind of systems force us to rethink of our model of formation and refine the actually there is a lot of physics behind these models which are very complicated. But for example, for the end of life of planets, it's good to observe system like MOA 477, for example. Finding this kind of planet shows that actually some planetary system can survive the death of their star, and so that can maybe help us to understand what's going to happen to the solar system when the sun's going to become a red giant and before explosion. For example, it's very unlikely the Earth would survive that, but maybe Jupiter, maybe Saturn also. We don't know. So we need to observe more of these exotic systems to understand the future of the solar system, I would say.
Yeah, I think up until 10 years ago, we didn't know whether planets could survive their stars going red giant and becoming white dwarfs. And now we've seen lots of different kinds of planets and planetary remnants around
Yeah,
white
yeah,
dwarfs. So we know something survives past this stage. So
yeah,
fingers crossed it's us.
yeah, yeah, yeah.
Well, thank you, Etienne, and thank you everyone for joining us. If you want more out of this world astronomy content, please follow us on Instagram, Facebook, and Twitter, where you can send us your burning questions about exoplanets, real or fictional, and beyond for us to tackle in an upcoming episode. Bye.
Thank you. Bye bye.